In this video, I am going to demonstrate how to visualize the sensor data in Unreal Engine version 5. The sensor data we have captured in terms of pitch, roll and yaw will be transmitted to Unreal Engine over Wi-Fi. My final goal is to retarget the data to human rigid body. To start with, I will first point the data to a small cube and observe the cube's behavior along with the sensor orientation. I am sure it will be fun when I will be able to see the same sensor orientation in the computer 3D animation. After applying a lot of knowledge on raw sensor data of accelerometer, gyroscope and magnetometer, I had evaluated the orientation in terms of pitch, roll and yaw with some limitation. It was not so easy. A lot of deep learning was involved to determine the correct rotational angles. If you have not watched the previous video on accelerometer, gyroscope, magnetometer, low-pass filter, sensor fusion and complementary filter, please check the description below. You can also visit to my Patreon site to read the complete paper. Here are the steps I will follow to achieve the first part. At first, connect my ESP32 to my local Wi-Fi setup. Then I will package my sensor data to JSON string to transmit, and using asynchronous UDP protocol, I will transmit the data to Unreal Engine. To visualize the data in Unreal Engine, I will create a project and make a static mesh cube structure. By enabling an UDP receiver in Unreal Engine, I will be capturing the data which has been transmitted from the sensor. Finally, I will point those data to the cube rotational axis. A lot to cover in one video, so let's get into it. If you are new to this channel, please consider to give a like and subscribe. That means a lot to me. Before I start making changes in the existing code, I have done some housekeeping to make the code clean and simple. I am using the same code from the previous episode of Magnetometer. If you are following me, you can download the same source code from my Patreon site. It is free. In the code, I have removed all the serial prints which I used to plot the data except calibration output and pitch, roll and yaw values, as all these values will be sent to Unreal. The ESP32 is an amazing device which has built-in Wi-Fi module. There are two modes we can configure in ESP32 device: STA station mode or AP access point mode. To connect to existing network, we need to use station mode. That's what I will do in this. I will pass my Wi-Fi credential and connect my ESP32 to my local Wi-Fi. Problem in this process is I must hardcode the network name and password in the sketch. Every time I change the network and password, I will have to change the sketch. To avoid such issue, AP or access point mode is used, which creates its own network. Once the network is created, if we launch a web server in ESP32, then we can take user input to the device to connect to local Wi-Fi. Then we do not need to hardcode the local Wi-Fi's credential in the sketch. This part is little tricky, which I will anyway implement when I create the UI in Unreal Engine, so please stay tuned. To enable the Wi-Fi module, I had to include WiFi.h in the header. Here in the code, I have defined my Wi-Fi credential, network name and password. Followed by, I have given 20-second timeout for connection limit, as I do not want my ESP32 to keep trying forever. If it fails to connect within 20 seconds, then error will occur and user will need to check the credential or the Wi-Fi settings. I am keeping all the exceptions and error handling for the later videos. I have created a function called connect to Wi-Fi. In that, I have created my ESP connectivity code using the station mode. This part of the code is self-explanatory. At first, I set up the Wi-Fi mode, then calling the begin function with the credential to initialize the Wi-Fi to establish the connectivity. Here I have created a variable to capture the initial startup time in milliseconds. Finally, in the while loop, I am checking the status of the Wi-Fi and the connection timeout between the start of the process till now. A 100 millisecond delay is added to ensure the overhead of calling Wi-Fi status function. Finally, once the program comes out of the while loop, I am checking the Wi-Fi status. If connected, then I will continue, else nothing will be done. That means ESP will not initialize the sensors. All such error handling I am keeping it for later stages. For the time being, let's consider the Wi-Fi connectivity goes well. In the startup function at the beginning, I have called the connect to Wi-Fi to ensure the connectivity for the data transfer. Please note the function call should be done after initializing the serial port, otherwise nothing will be printed in the serial port. After uploading the code, here in the serial monitor you can see my ESP is successfully connected to the Wi-Fi and have got an IP address as well to set by the router. To validate that, I logged in to my router portal and see ESP32 with the same IP address. It means my code worked perfectly. That's it. Now it's time to move to the second step for packaging the sensor data in JSON format before transmitting. JSON or JavaScript Object Notation is a lightweight data interchange format. It is easy for human to read and write, for machines to parse and generate. It is based on a subset of JavaScript programming language standard EMA 262. JSON is built on two structures: a collection of name-value pair. In various languages, this is realized as an object, record, structure, dictionary, hash table, or associated array. Second is an ordered list of value. In most languages, this is realized as an array, vector, list, or sequence. These are universal data structure. Virtually all modern programming language supports them in one form or another. It makes sense that a data format that is interchangeable with programming language also be on the same structure. There are other various protocols such as MQTT, ASN.1 and so on. But for me to start with, let's build a simple structure. In future, I will explore those as well. To start with, Arduino has a library called Arduino JSON, which I had to install from my Manage Library section. Once the library is installed, I have included the header ArduinoJSON.h. To separate out the code, I have created a function called getJSONString, which takes sensor name, pitch, role, and yaw as an input, and in return, it will give a JSON string. The process is very simple. Arduino JSON library will manage all the internal transformation of the value to the JSON string. At first, I have initialized the JSON document, and then using name and value pair, I have created the object. Once the object is created, I have serialized the object to a string which is finally returned from the function. Simple coding. Finally, from the loop, I have called the function to convert the values to JSON object. I have declared the JSON string at the beginning to make it global. This will help in memory management of ESP32. Sensor name is one of the important aspects in this. In total, I will have 17 sensors, so for Unreal Engine, it is important to know which sensor's data it is. Maybe I also need a suit name if in case I need to point to multiple character rigid body. We'll look into it later. Finally, to test the code, I have added the serial print of JSON string. Here you can see the JSON data which is packaged after evaluation of pitch, role and yaw. The output is nice and clear. Now it's time to transmit the data to Unreal. There are two ways to transmit the data over the network: TCP and UDP. UDP, User Datagram Protocol, is a communication protocol that is primarily used to establish low latency and loss tolerating connections between applications on the network. UDP speeds up transmission by enabling the transfer of the data before an agreement is provided by the receiving party. TCP is a connection-oriented protocol, whereas UDP is connection-less protocol. A key difference between TCP and UDP is speed, as TCP is comparatively slower than UDP. Overall, UDP is much faster, simpler and efficient protocol. However, retransmission of lost data packet is only possible with TCP. To enable UDP, I have included the header async UDP. I have defined the server's IP and the port where my Unreal Engine is running in the same network. I have given a port 3002, assuming that my Unreal's UDP server will be running on the same port. When I configure Unreal, I will use the same port. Here I have created a client object from the async UDP to deal with the data transfer. I have created two functions to deal with connectivity and data transfer. Those are UDP connect and UDP send data. In the UDP connect function, at first I have initialized IP address from the server variable and the connect to the port using the async UDP client object. This is pretty straightforward. The second function is the one which will transmit the data. The input to the function is the JSON string. At first, I am converting the string to the character buffer. Then I am broadcasting the message if the client is connected to the server. As I am broadcasting the message, even if the server is not running, the client will not stop or complain any error. This is the primary reason of choosing UDP communication. Finally, in the loop, after constructing the JSON string, I have called the UDP sendData function with the JSON string as an argument. It is always recommended to segregate the functionalities in multiple files instead of multiple functions. In the later episode, I will create multiple file objects to separate the functionalities instead of overloading all in one file. It will be easier to read and make modifications. That's all of the coding in ESP32 device or in Arduino. Now it is time to work on Unreal to visualize the data. I will be using Unreal Engine version 5. In the Unreal Engine, I have created a project called Unreal 5 Playground. You can choose your own name. This is a blank project without any startup content. The target platform I have chosen is desktop with maximum quality preset. My PC is 16 core with RTX 3080 graphics card. If you have lower configuration, then you can use scalable options or give it a try with a maximum quality. At this moment, I have not enabled the ray tracing option as I do not have much idea about that. Once the project is created, I have got a simple scene with a floor and ambient light. I do not have any experience in Unreal Engine so far. I will create another playlist of Unreal learnings as well in parallel. For those who are new in Unreal can follow the playlist as well. For the time being, let's continue with how I have made this work in Unreal. At first, I need a plugin for Unreal to establish the UDP receiver to accept all the data coming out of the device. To do that, I have downloaded a package from GitHub called UDP UE4. This package has a dependency on another package called Socket.io client UE4. Both the links are there in the description below. The downloaded package I had placed in the project folder under a plugins directory. I had to create a new plugin directory as it was not presented by default. Then I restarted the project and found an error complaining the plugin's compatibility. As you have noticed that these plugins are intended for Unreal version 4. Although Unreal Engine 5 tries to rebuild the plugins, but for me it failed and asked me to rebuild these plugins from the source. To download the socket client source code from the Git, I had to use the recurse command as the package has got a submodule and the dependency with all other JSON parsing and all. Command is there in the description below as well. This was a bit tricky for the beginner. I had to upgrade my .NET framework and whatnot, but somehow I managed to compile those two plugins. If you want to compile those two plugins by yourself, you can follow the commands. However, I have already uploaded those compiled code in my Patreon site as a zip file. The link is there in the description below. You can directly download those from the Patreon site, and after unzipping it, you can place those in the plugin folder. After compilation, I have placed these packages into my plugin folder of the project root directory and restarted the project. Now if I search in edit plugins, I will get UDP-Wrapper.uplugin already enabled for me. There is also another plugin called UDP Messaging, which is not enabled by default. Not enabling it will not cause any harm. I can live without it. But in some forums said UDP Messaging is a plugin that connects messages bus running in different instances of Unreal Engine over the network. The message bus is a communication infrastructure for exchanging structured data within same process. UDP messaging makes it possible to send and receive messages between different processes on the same computer or between multiple computers. It is used by a number of tools, especially in Unreal frontend for remote profiling, automation, game session discovery, and device management. Anyway, I have leave it enabled for the time being. Now my plugins are ready to use, and it's time to make a static mesh for cube and a blueprint. A static mesh is a piece of geometry that consists of a set of polygons that can be cached in video memory and rendered by the graphics card. This allows them to be rendered efficiently, meaning they can be much more complex than other type of geometry such as brushes. Since they are cached in the video memory, static meshes can be translated, rotated and scaled, but they cannot have their vertices animated in any way. Static meshes are the basic unit used to create world geometry for levels created in the Unreal. To start with, I have created a blueprint object in the blueprint folder and named it cube. Then in the details, I have added the static mesh cube component and dragged the blueprint class onto the floor with transformational property like an aeroplane. The reason of creating the object as a blueprint class is to access the cube from other blueprint, so that based on the data received from the sensor, I will be able to rotate the cube programmatically. From the world outliner, I can change some of the properties of the static mesh like color, physics and so on. But for the time being, I am going with all the defaults. A lot more things are to be covered in static mesh, which I am keeping it for the future videos. Here in the details section of the cube, there are 3 transformational properties of my interest, which I need to know and play around: location, rotation and scale. Location specifies the cube's location in the world in terms of X, Y and Z. Rotation specifies cube's orientation in terms of X, Y and Z, or pitch, roll and yaw in its 3-dimensional reference frame. Finally, scale specifies its shape. From the sensor, I will be sending rotational details, pitch, roll and yaw. To map those details in the cube, I need a blueprint. The blueprint is a visual scripting system in Unreal Engine. That is complete gameplay scripting system based on the concept of using a node-based interface to create gameplay elements from within Unreal Editor. As with many common scripting languages, it is used to be defined object-oriented classes or object in the engine. In short, Blueprint is a scripting tool to program the behavior of any objects. More on the details are kept in the future video. To create a blueprint, at first I have to create a folder called Blueprints in my content directory. In the directory, I have added a blueprint class of type actor and named it UDP controller. The role of the blueprint class is to capture the data coming out of my sensor. I have placed the class in the world by dragging and dropping. Once the actor is placed in the world, I would be able to see the class in my world outliner. There are several properties can be set in the blueprint by clicking the link given in Edit UDP controller from the world outliner. I am keeping all these parameters as a default for the time being. Double-clicking the blueprint in the content browser will open the blueprint editor. Event graph is the section where all my scripts will go. By default, there are 3 events configured: event begin play, event actor begin overlap and event tick. I have used event begin play only. Other events I have deleted. At first, I have connected the event begin play with a function called openReceiveSocket, which is exposed from the UDP component. Here I have configured the listen port of 3002. Listen IP can be restricted for a specific device. For the time being, I am allowing all IPs as a sender. In the component on the left hand side under UDP controller, I have added a component called UDP, which I have connected to the openReceiveSocket function as a target. The variable UDP is also connected to a function called closedReceiveSocket under UDP component. The trigger for the function will be event end play. The next step of the openReceiveSocket is bind event to onReceive bytes with the target of UDP. Now it's time to create an event to accept the bytes coming from the UDP. The UDP wrapper has an event created which is by default are not accessible by the blueprint editor, and hence I have to create a custom event by the same name called UDP received event, which I have linked it with the bind event on receive bytes node. Now it is time to print the data on screen. To print the data on screen, I have converted the bytes to string using toString function and passed the string to another function called printString. Now if I compile and run Unreal Runtime, I see the cube and the data coming from the sensor printed on the screen. That means my UDP communication is established and transmission is completed. Now it's time to target the data to the cube. To do that, at first I have converted the JSON string to JSON object using a function called toObject and then extracted all the values by name to a number field. Using Kismet math library function called makeRotator, I have joined all the data to a rotator object. The pitch in Unreal is Y and roll is X-axis, so I have pointed the values accordingly. To apply the rotational matrix to the cube, at first I have to get the cube actor of class and followed the execution path from the bind event on received bytes. Then linked the cube instance to setActorRotation function. SetActorRotation function accepts the new rotation, which I have linked from the makeRotator output. Now to complete the execution path, I have linked the printString execution path to setActorRotation function. It means when the data will come from the device, it will first print on the screen and then apply the new rotation to the cube actor. Now it is time to test. On playing Unreal, I could see the orientation of the cube, which is appearing same like the way my device is. It is responding nicely to roll and pitch. It's really amazing, and I made a good success on the visualization. The yaw direction is opposite to the sensor direction. Rotating to east, it's rotating to west, and the same for other side as well. It's kind of following anti-clock direction. To fix that, I have just multiplied the yaw with -1 and the result is perfect as the way I wanted. To avoid printing on screen, I have deleted the print screen function and directly linked UDP received bytes node to the setActorRotation. This way my screen looks more cleaner. I have played around with it for some time and so far nothing has been broken. Overall satisfactory result. Targeting this data to human rigid body is complicated and need more learning. I will cover that in upcoming video. Before that, I will make another sensor so that when I point to human rigid body, say on the hand, at least 2 sensors will be pointed and the visualization will make more accurate. I also need to revisit the cost. If I go 1 ESP per BNO055, then my cost will go up and I will not be able to finish my suit within my budget. Therefore, I need to implement multiplexing, that means integrating 2 or more BNO055 with 1 ESP32 controller. Let me keep that for next video. As you know, the thing I am trying is huge and it is next to impossible for beginners like me or an individual. But my confidence say I will achieve that, as nothing is impossible. Most of my time is spent on research and finding the solution from communities. Based on the time spent on learning last few weeks, I have made this video to demonstrate my learning. I might be wrong and not able to explain it properly. If you could point out those problems or better way of doing it, it will be a great help. So please comment and help me. On that note, I am finishing this video here. I hope you like the progress and the strategy of the development. Please stay tuned for such interesting topic and the solution. Till then, stay safe and take care. Thank you for watching.